Welcome on this e-learning platform of Apex Institute of Physics. Here is the general information about the instructor and the course. In this video we will continue with the Coulomb's law. So let's proceed. In the previous video we came to know if there are 2-point charges Q1 and Q2 separated by a separation which is written by R. So the force of interaction F is given by K Q1 Q2 upon R square, where the term has their own meaning, and these had been explained in the previous video. Now this force has some important points or properties that we deal here. It says the first point says the force is conservative in nature. That means if we calculate the work done by this force, this work done by the force will not be wasted, rather it will be stored in the form of energy. So this is conservative in nature, so its energy is being stored. That means we can define this work done as minus change in potential energy of the system. So we can define the potential energy corresponding to a conservative nature of force. Moreover, if somebody asks what is the value of this closed integration F dot dr, where F is electrostatic force, we will find for a conservative force this is always 0, which is trying to say the work done by the force in a closed curve. So in a closed curve, work done by a conservative force is always 0, and for a conservative force work done is always equal to minus change in potential energy. Or we can call it in a different manner, that the work done by a conservative force is path independent. So these are all related to conservative nature of this force. Now this force is called inverse square law, simply because F is proportional to 1 upon R square. So whenever a force is proportional to 1 upon R square, so that's called inverse square law. Now the next point is about the interaction forces. So these interaction forces that acts, they are opposite in direction. We have already talked. They have equal magnitude. We know that, and they act simultaneously on the two different bodies. So when the force F1 will act on Q1, F2 will act on Q2, and that will be simultaneous. Moreover, further studies has revealed that this electric influence that get transmitted through this space, and that transmission is with the velocity of electromagnetic wave. That means corresponding to the speed of light. And it is being supposed that the two charges, when they interact, and that interaction is due to continuous exchange of photons between them. So one charge and another charge, they exchange photons and in turn apply a force, this electrostatic force. So that's a theory deep inside. Another property related to this force is that it follows principle of superposition of forces, because the interaction between any 2-point charges is independent of existence of all other charges. That means if this is plus Q and this Q1, so this F1 force acting on it will be independent of presence of Q3 or Q2. Similarly, the interaction between Q3 and Q, that means this F3 will be independent of presence of other charges, and similarly this force will be independent of presence of other charges. Hence the net force is equal to F is equal to F1 plus F2 plus F3 and so on. That's called principle of superposition. Right. Now electrostatic is a fundamental force. So if we consider the force between two electrons, let's say one electron is there, another electron is here, and let's say they are having a separation R. So interaction due to electrostatic is written as K E into E divided by R square. And if we consider their gravitational interaction, that's going to be capital G mass of electron upon R square. If we put their values, then we'll find this force is roughly equal to 10 raised to power 43. That means electrostatic force is much more greater than the gravitational force. So the strongest force is a nuclear force, then electrostatic force, then gravitational force. So this is the order of their